Welcome to Algebra 2, Unit 7, Lesson 12 Practice Problems. Today we start with one vocabulary term, and that is margin of error. The margin of error is the maximum expected difference between an estimate for a population characteristic and the actual value of the population characteristic. So if we find the mean, then the margin of error is the range between how low that mean could possibly actually be at and how high that mean could actually be at with a 95% confidence level. In our first problem here, it says technology required. I'm going to show you how I used Google Sheets to work on this one. It says the mean amount spent on daycare yearly by random samples of 10 families are listed. Use the values to estimate the mean amount spent on daycare yearly for the population and provide a margin of error, round to the nearest dollar. So, I've already used Google Sheets to do the math, so I'm going to walk you through what I did. The first thing you're going to need to find is the mean. To find the mean, you're going to add all the values then divide by the number of values. So I'll show you the Google Sheets. In this left column, you can see that I input all the values from that question. I added them all together and I divided by 10 because there were 10 values. And rounded to the nearest dollar, I got a mean of $9,494. The next thing you have to find is the standard deviation. To find the standard deviation, you're going to take this mean and you're going to subtract it from each of the values. Once you have found each of these differences, you're going to square each of them. Once you square each of the differences, you are going to add all these squared differences together. Then you will divide by 1 less than the number of values you had. In this case, since we had 10 values, we would divide by 9. And the last thing you'll do is take the square root. So I'll show you the Google Sheet. Okay, in this first column in A, we had all the values, and we found our mean. Then what I did was I programmed each of these cells to be the value minus the mean, and that's what all the values in B are. In C, I had each of those values in B multiplied by themselves. Then in this cell right here, I added all of those squared differences together. Then I divided by 9 because we had 10 values, so I wanted to divide by 1 less than the number of values I had. And then for the standard deviation, I took the square root of that. So our standard deviation is 2,259. And the last thing we needed to do was find the margin of error. We're going to multiply the standard deviation by 2. This way, we are within 2 standard deviations above and 2 standard deviations below. So if you look at the Google Sheets, this cell right here was the standard deviation multiplied by 2, and our margin of error is $4,519. So here we would expect the mean to be at $9,494, and 95% of all results to be within 4,519. If you have any questions about how to calculate the mean, how to calculate the standard deviation, or how to calculate the margin of error, please ask for clarification now so that you're better prepared moving forward into the other practice problems. In our next practice problem, again, notice it says technology required. I used Google Sheets. You can see it on the left side of the screen. It says 25 random samples of 30 people each were measured for their daily water usage. The mean for each sample is included in the dot plot. So each of those dots is one of the 25 samples, and it's the mean for that sample. Use the values to estimate the mean water usage for the population. What is the margin of error for this estimate based on these values? Round to the nearest tenth of a gallon. So, first I needed to find the overall mean. What I did was I took each of the values that had dots and I multiplied by how many dots there were. So, multiply number of dots in each value by the value, and I added them together. Then I divided by the number of values. In this case, there were 25 of them. So I took each value, I multiplied it by how many dots there were, and I got the total value, added them all together, and divided by 25. And this gave me my mean of 124.8 gallons. Then, to find my standard deviation, I subtracted the mean from each value then I took that difference and I squared it. Once I got the squared differences, I multiplied by how many dots were in that category. That allows me to add them together and then divide by one less than the number of values. So you can see that I divided by 24. Then I could take the square root of that and I found my standard deviation. and my standard deviation was 7.8 gallons. Now, if I want the margin of error, I multiply standard deviation by 2. So that was the 7.8 times 2. And because this keeps track of all the decimals, this rounds to 15.7 gallons. So while we believe the mean is 124.8 gallons, for a 95% confidence level, it could be all the way up to 140.5, or it could be all the way down to 109.1. This would be 2 standard deviations above to 2 standard deviations below, and that would be our 95% confidence margin of error. If you have any questions about how to calculate the mean, how to calculate the standard deviation, or how to calculate the margin of error, please ask for clarification so you are better prepared as we move forward into the next practice problem. And our last practice problem for lesson 12, select all of the values for the population mean that would be plausible based on an estimate of 105 centimeters with a margin of error of 21 centimeters. So our mean is the 105 centimeters. If our margin of error is 21 centimeters, then adding 21 centimeters would put the top end of our range at 126 centimeters. Subtracting 21 centimeters would put the low end of our range at 84 centimeters. So as we go through the choices, they need to be between 84 and 126. A is too low. B is in the range. C is the actual mean. D is in the range. And E is too high. If you have any questions about how to calculate the plausible range of values based on the mean and the margin of error, please ask for clarification so that you're better prepared and set up for success as we move on to lesson 13.